Number 1, converting minutes to degrees. So 23 degrees, 12 minutes is equivalent to 23 degrees plus 12 sixtieths. And then 12 sixtieths as a decimal is 23.2 degrees. There are some in reverse, such as number 5, where it says how much is 21.2 degrees written in minutes. So this one we'd like to write it as 21 degrees plus 60 times 0.2, which actually comes out to be 12. Converting degrees to radians, we simply multiply by pi over 180. And then simplify. Same type of problem in reverse, converting 71.72 degrees to radians. Now this one doesn't reduce that well, so we'll just write it as 1.25 radians. And then reverse converting radians to degrees. So like 17, we're going to multiply by 180 over pi instead of pi over 180. And when we do that, pi's cancel. We get 180 over 6, which is 30. One more like that, maybe 21. Same idea. We've got 7 pi over 9. So we multiply that by 180 over pi. And we end up with 140 degrees. And then one more, but this one's a little bit different because the radians you're given doesn't have a pi in it. It's just 1.3 radians to begin with. So we multiply that one by 180 over pi. We're just going to substitute in pi as approximately 3.14159 and come up with an answer that's a decimal answer as our final answer. For the next set of problems, we're using the formula S equals R theta and variations of that. So 26, they're telling us that R is 1, theta, which is supposed to be in radians, is 70. So our S is going to be 1 times 70. We should get an answer of 70 centimeters. This is 1 centimeter. If they give us a variation of that, so 28, they tell us a variation. They tell us S is 2.5. And then they tell us that theta is pi over 3. So we're supposed to work that backwards and say, okay, if S equals R theta, then R equals S over theta. So here we would write R equals 2.5 divided by pi over 3. Be a little bit careful dividing that out, but when you do, you should get about 7.5 divided by pi, which is 2.39. 33 is a similar problem. We've got S1 equals R1 theta, S2 equals R2 theta. So they tell us originally that R1 is 11, S1 is 9, both in centimeters. So we solve theta. So theta equals 9/11 radians. Take that answer, put it into this equation, because they've told us already that R2 equals 44. We just need to figure out what theta is, which we just did figure out was 9/11. So 44 times 9/11 is 36. For 35, we have a picture like this. We're supposed to find the length S. And it's telling me that each distance here is 11 inches. So if S equals R theta, the equation we're working with, the R is 11, the theta has to be in radians, not degrees. So I've got to figure out 10 degrees times pi over 180 gives me about, well, pi over 18 radians. So my arc length should be S equals 11 times pi over 18. And that's about 2 inches. So the perimeter of the entire shape would be 11 plus 11 plus approximately 2. Would be about 24 for the entire perimeter of the shape. For 37, 10 pieces of track form a circle. So each piece is going to be 1/10 of the circle. So the circumference is 2 pi. Each piece is going to be 2 pi over 10, which is pi over 5. So the outside arc would be R2 times theta. The inside arc is R1 times theta. And that difference, it says in the problem, should be 3.4 inches. So that means the outside minus the inside radius should equal 3.4 times pi over 5, which is about 5.4 inches. So the first part of number 43 is in calculating the two boats are traveling at slightly different directions, and you're supposed to calculate the angle in between the two boats. So take the angle the first boat's traveling at, which is the 52 degrees 12 minutes, subtract away 42 degrees 30 minutes. You've got to subtract a 1 here, make this into a 72. 72 minus 30 is 40. Oops, 42, sorry. And 51 minus 42 is 9. So it's 9 degrees 42 minutes. That goes in between the two boats. From there, it says the boats have traveled 25 miles so far. They're going the same speed. So we're basically finding the distance right here between them, which we will call S. So since S equals R theta still, we simply type in 25 times times, now theta has to be in radians. So we've got to convert 9 degrees, 42 minutes into radians. .7 degrees times pi over 180 gives me about 0.16 radians. That's what I'm going to make sure I use for my theta. So 25 times 0.169 is approximately 4.23 miles.